Okay, so this morning we're looking at the gravity lab from STEMScopes in the student guide, student journal. These can be found on Canvas in the gravity module. To get started, if you're having to do this as makeup work, we have the background questions can be found in the background information. So you should be able to read this example over here and answer these questions about background of gravity. So that's pretty easy. And then our next step, if you're following along in the student guide, we do part 1, bigger the better, and it lists off how we would have divided the class into 2 groups of equal size. Group A will stand at their location, B will stand at their location. Teacher will select one student to be an object positioned in between the 2 masses. So this is some imagination on your part. Student will choose which floor marking is the most appropriate location for the object. Half of the students in Group A will move to the members of Group B. The student or object moon will choose a new location appropriate for the change. What we did is, instead of this, is we did a tug of war. And so if you want to do some more imagining, we imagined that, or we put 2 equal-sized masses on either side of the rope and did a tug of war. And obviously it lasted a long time, and the force being pulled by each side, because the masses were equal, was fairly equal, and the rope didn't move for a long time, and then it finally went to one side or the other. And then our next experiment that we did to demonstrate this is we put the entire class on one side and one student on the other side. And when I blew the whistle, the entire class pulled, and the one student was pulled, obviously, across the ground until he or she let go. So what we demonstrated with that was the larger mass is going to exert a greater gravitational force. The large number of people on one side of the rope pulled with more force than the one person on the other side of the rope. So that's how we demonstrated that first concept in part 1. When we get to part 2, the bigger the better, you can read this background information. Procedure says look at the student reference sheet, and this is the student reference sheet that we're talking about. Use the comparative sizes for each of the objects to arrange them in an ordered list from largest gravitational force to least gravitational force in your student journal. So you have to figure out, based on what you've learned, which one of these has the largest gravitational force, which one has the least, and put them in order from the largest, highest gravitational force to the lowest, and then answer the questions on that section. Okay, so that takes care of part 2. Part 3. How far is too far? We were looking at how distance affects the gravitational force, and so that gives you some examples of what we're talking about with equal mass, large mass, small mass, and then we look at the difference with distance. So you read through this. There's nothing really to write down about that. This says to plan your investigation. We didn't do our own investigation. We used the one out of the book, which is this one here. And so it walks us through the steps of having the different books. And you can see they have we have 2 textbooks, and then we have the cardboard in between them. We put the paper clip on there, we put the magnet underneath. It goes through a very thorough process to see, and what we're doing is we're seeing how the paperclip reacts to the magnet with varying numbers of cardboard in between. So your job is we used file folders. You can use cardboard. This is the back of a legal pad is what we're going to use right now, but we took our magnet and our paperclip, and with 0 layers of cardboard in between, we tried to see how does the magnet affect the paperclip. So you can determine how that affects it. And then we wrote down our response. Didn't worry about the thickness because we didn't want to try to measure millimeters on this. So we didn't do this last column. We're only worried about our observations. Then we put 1 layer of cardstock in between the magnet and the paper clip and tried to see how is the paper clip affected by the magnet. You can still see that there's a pretty strong attraction still going on there. And so then I wrote down my observations with 1 layer. And then we added a 2nd layer. Same thing, magnet, paperclip, but we get 2 layers. and we're looking at the attraction between the two. You can write down your observations for 2 layers. Then we moved on to 3 layers. Same process. Notice that my hand is moving a little bit faster than the paperclip is at this point. Okay, same process. Here's with 4 layers. And then with 5 layers. You can see sometimes the magnet slips off and I lose the paperclip. And then finally with 6 layers. So I don't see the paperclip moving on this once we get to the 6th layer. There it is a little bit. Okay, so then we fill in our observations for that part and then analyze our data. What did we learn from that? So you'll just answer these questions on here about how the magnet worked with that. And then when we finish up, the reflections and conclusions, we did not do our own experiment, so we don't answer the first question. Actually, I would leave this out completely. This only applies to the thing, so don't worry about that. We're going to leave those out. So the last part is just this analyzing data. So what we're looking at is the 2 factors, the 2 different variables that affect gravity. And one of them was when we did the tug of war and we had different sized masses on either side of the tug of war rope. And then we used the distance between the 2 to demonstrate the 2 different variables and how they affect the gravitational pull. I do want to throw in one warning. We used magnets over here to demonstrate gravitational attraction. Gravity and magnetism have nothing to do with each other. So gravity is not caused by magnets. Magnets do not cause gravity. Gravity is a force that's related to the mass of an object. And so we use this as a demonstration. Please don't confuse magnetism and gravity because they are 2 totally different things and have nothing to do with each other. As I told class, it's not like because we have iron in our body and the earth is a giant magnet, the reason that we stick to the earth is because the magnets in our feet or the iron in our feet stick to the magnets in the ground. That is not the case. So again, magnets and gravity have nothing to do with each other. And that should help you get through everything we did with the lab yesterday.